Good evening, afternoon, morning, wherever you are listening to this. It's another Weather Wednesday. It is going to be episode 6. This one is going to be ice and temperature inversions and basically winter weather operations. Some people. I'm at home right now in Pennsylvania, so it's currently cold here. Normally I'm in Miami. It's a much normal, mild weather. So you don't normally have to worry about winter operations, but up anything basically north of, I don't know, Tennessee, you basically have to worry about some sort of winter weather, especially going into this month. I got Mike Gronke again with me. He's going to help walk us through some of this and talk about the ice and temperature inversions and things like that and how that can affect you as you're getting ready to go fly. Mike, again, it's good to have you back with me.
Yeah. Talking about cold weather, and I will give the disclaimer: I'm getting over a cold and may have a little cough, so apologies for me. If it really gets bad, I will mute my audio. Hopefully, it's not that bad. The
It's all right.
drink, so. All right. So we'll get into it here. Like you mentioned, temperature inversions, winter operations. We decided to put two together because temperature inversions directly impact different types of precipitation in the winter. Although I do want to start out by just saying temperature inversions happen all year. They're not a winter thing. But they do. They're the literal reason for us having more than one type of precipitation. So it definitely goes together pretty well. So let's start off here. Share the screen. So got to hear what is the temperature inversion? What are the impacts to flying? How does it impact the weather? I got a few of those answers down here. But the first off with what is temperature inversion, I will go to my crude graphic. That sorry, it's a little blurry. But as like I was joking you before, Brandon, it's almost so dumbed down. It's perfect.
Yeah.
Um, so on the left here, under normal conditions, the way it works is as you go up in the atmosphere, so we start off over here down on Earth, on the ground, and you go higher in the atmosphere, it typically gets colder. That's just, at least in the troposphere is what we're talking about with weather. Um, so you got warm air that you can see there, you got cool air, so cooler relative speaking, and then even cooler farther higher up. When you have a temperature inversion, you have basically a layer of warmer air above where you currently are, which is abnormal. So you start off with the cool air at the ground, and then as you come up, you come into this warm layer of air. And there is colder air above it, but there's that warm layer, and that warm layer can do quite a few things. Probably the most notable is the way you see this orange arrow pointing here on the left. You can see that air it's going all the way up. That allows for lots of vertical mixing in the atmosphere. And on the right here, that orange air basically that's like if air is trying to be lifted up, it hits that inversion, and it's basically like a lid, and that air gets sent right back down to the ground. So a couple things with that. Number one, how does it impact flying? Well, wind shear is definitely a possibility when you have inversions. Not a guarantee. I will give I'll give the reason why you can have wind shear and then why it's not a guarantee. But so when you have normal conditions here, you have a little more mixing in the atmosphere. You can still have wind shear. There can still be, we'll say a strong jet stream aloft, and as you fly up into that, you get some turbulence because there's wind shear. However, when you get this inversion here on the right, the air does what we call decouples, or instead of all being kind of mixed together in the low several thousand feet, there's kind of like this. It's like putting like a lid on the atmosphere basically, and it's a hard line where you have the air can't get through it, but also the air higher up is now no longer associated with the air at the ground. So when you have that air mixing like it normally does, you get friction with all the trees and the houses and the hills and whatever on the ground, which is what slows the wind down. That's why you never, we talk about jet streams aloft. They're 50, 60, 70 knots, 100 knots. Obviously, that really never happens at the ground, and that's mostly due to friction. So when you have this inversion and you completely decouple the air near the ground with the air above, you no longer have any friction. I mean, at 5,000 feet, there is no friction. But you don't have any of that element of it mixing together and kind of slowing it down in general. You just have the air below the inversion and the air above it, and the air above it is free to move, and whatever wind forces are occurring with the jet stream are free to happen with no harm from friction. So that's why I say it's not a guarantee though, because it depends on what forces are happening. If you recall from our few videos in the past.
Hey, time out, man. I can't hear you. Uh-uh. I've lost all audio for you. Ah, wait a minute.
It's back.
Yeah, the moment you stop sharing, it came back. So
Sometimes it happens a little
yeah, so
bit.
I don't know exactly. I don't know exactly where you stopped. You were talking about the air being able to free to move up here, and then down here you had that cap off on it. So you get that shear in between. But
Yes.
that was about the last thing. That
Okay.
was the last thing we got. Um, and
Are
honestly,
we gonna do the all right and cut?
now this time I'm just gonna play it off. I'm gonna say
All right, let's do it.
let's just roll through it. I'm just gonna leave
You
it
know
in
what?
and go through. We had a couple
Sometimes
technical difficulties. It's not a big deal. We'll just keep going with it. Um,
sometimes this happens with the internet. This is how it goes.
right. So hey, let me ask you real quick though
Yeah.
before you hop back into there. So well actually it's not really asking you when we were talking about the effects of flying. So you know, for anybody that has flown or anybody that has looked into or researched, you know, how airplanes work and that kind of stuff, obviously the effect that this is going to have whenever you have this inversion where the warm air is above the cool air, one thing you have to remember is that you're going to have a decrease in aircraft performance. That's going to be a huge thing. You know, cool air, airplanes love cold air. They perform better in cold air, like even to a point where sometimes we have to tell the airplane that it's warmer outside than it actually is, to be able to not get as good a performance as it can give us, depending on certain situations. So just realize that if you're coming into something where it's going to be an inversion, that you're going to have good performance and then you're going to have a degrade in performance and then you're going to have good performance again once you get through that inversion.
Yeah.
But just something else to think about.
And that's going to also vary by how severe the inversion is. I mean, there's cases
Sure.
where I've seen where it's, 5, 10 or more degrees warmer in this inversion layer. And that's probably where that's going to happen. Other times you're going to have where it's just a small inversion. But from a weather perspective, the same thing is still happening. It's just you may not get the aircraft performance loss if it, I'm assuming I'm not a pilot, but if the air temperature goes up 2 degrees for a couple thousand feet and then continues to drop after that, probably not a huge deal. Versus
Yeah,
10 degrees.
probably not so much for 2 degrees. I mean, it really depends on a lot of it would depend on the situation. So like
Yeah.
Bogota, for example, like when aircraft go into Bogota, so primarily, you know, we've talked about I instruct on the 7.6. You know, so we're talking about airplanes that can take off at about 450,000 pounds gross weight, uh, with about 60-ish thousand pounds of thrust per engine. Well, when you have 1 or 2 degrees of a temperature difference at 8,400 feet pressure altitude or 8,300 feet pressure altitude, that couple degrees could matter. But
Yeah.
if you're taking off out of Cincinnati and you're going to like Nashville, yeah, that 2 degrees probably isn't going to matter so much. So
Yeah. Yeah,
it's
that makes
really,
sense.
yeah, it's really all situational dependent.
That makes sense. So speaking of situational, we were talking about shear. Whether there's wind shear and therefore turbulence with an inversion is also a little bit situational. So if you have a low level jet, so we'll say like there's some strong winds 5,000 to 6,000 feet off the ground, you're probably gonna have a little bit of wind shear regardless. So whether there's an inversion or not, but an inversion makes it more likely that you're going to have calm winds or fairly calm winds down near the surface and it's going to very quickly, when you break through that inversion, ramp up to 50, 60 knots or whatever it is at that level. And that is when you're going to typically see in a TAF, the wind shear line, where it'll be like, it'll have all your normal TAF stuff, and then it might say wind shear, and then it gives you the speed change over the height change or the altitude change. So that is one possibility. But if you don't have any kind of weather system coming through causing a strong low level jet, there probably isn't going to be a whole lot of wind change when you break through this inversion. And so, it's just like anything else in weather. There is no all the time this occurs, and this is the answer type of thing. But it is one thing, or we'll say quite frequently associated with inversions. I think is wind shear, just because of that chance of the if you have that low level jet. And even if it's not like a big storm system coming through, you may even on a more average basis, we'll say, still have at least some degree of when the air decouples, you get that wind to 5,000 feet going a little faster. Even if it's 20 or 30 knots, I mean, it's still 20 knots of wind shear certainly matters.
Yeah.
Certainly can still be kind of bumpy.
Now, is there an altitude? Is there an altitude that usually gets associated with inversions? Like
if you're doing a classic, near it's usually near surface inversion, so it might be like 1,000 feet, between 1,000 and 4,000 feet, we'll say. That is what's going to happen. That's what happens on most nights. Almost every single night, there is some kind of temperature inversion, unless it's like maybe like super cloudy or there's a big storm system coming through. There's a bunch of wind and everything. But most of the time, there's an inversion at night just because the surface loses more heat to the atmosphere above and cools off more than the air higher up in the atmosphere. So your classic, calm, clear night inversion is going to be, a couple thousand feet. When we get to the winter weather stuff here in a minute, that's where you can have an inversion higher up. But that's more driven by like a warm front or some kind of other like a weather system is causing the inversion versus it's just naturally occurring as the atmosphere kind of rests at nighttime, basically. Does that make sense?
Yeah, yeah. So basically, we can look at natural occurring inversions being something where it's the land cooling off and basically letting that warm air rise, so it gets cool down here and that warm air goes up here. Versus, it's still natural, I guess, but something coming in and actually physically changing,
right. Yeah, I'm talking more about the atmosphere being uninterrupted. Natural state overnight versus there is a force coming in, like some kind of weather system that is disrupting the profile of the atmosphere, basically. So I have some lists on here: impacts to flying, impacts to weather. So the big one's wind shear. The rest of these here are impacts to weather, but it also impacts your flying. So fog. This is your clear, calm night situation, right? So you basically when that inversion sets up, it's trapping in the air down below it because the air can't break through. If the air tries to rise, normally you have classic unstable conditions. The air rises up into the atmosphere, because it's warmer than the air around it. That air can't get through that inversion, and so it's stuck. And so if you have a low level moisture possibly trapped under that inversion, you're going to probably get fog, maybe even low ceilings. If a lot of times the ceiling is at the inversion point, so maybe there's an inversion that starts at like 800 feet. You got overcast deck at 800 feet because the temperature and the moisture is stuck there and can't get through it. And then hand in hand, poor visibility, but even poor visibility, I was thinking more for that in terms of like smog or smoke. So, if you are in a situation where you're in a place that gets, poor air quality or whatever, and the morning inversion is going to have worse air quality than during the afternoon when the air is more mixed up. I just went over clouds. So again, you can the inversion can get the clouds. I get to think of this happens more in the winter than it does in the summer, but you'll have days where everything is showing the inversion is going to break, the sun's going to heat through it, and we'll go back to normal. but it never does. And that's the day when it was supposed to be sunny and a high of 50, and ends up being cloudy and 41 because the inversion just never breaks, and and the clouds don't break, and so it just sits with you all day. So it can affect your cloud forecast. It can affect thunderstorms. So an inversion in the atmosphere is what we call a cap when it comes to thunderstorms. Basically, and this is probably this could be a surface or near surface inversion or one higher up in the atmosphere. But again, that we were talking before, that air gets trapped, it can't rise. Well, one of the four pillars of a thunderstorm is rising air. For that thunderstorm cloud to get 40,000 feet up, it has to rise, obviously. And so if the air encounters that inversion and can't rise above it, it's stuck. It's not, so you're not going to get thunderstorm development typically if you have a bad or a strong inversion. In the winter precipitation type. So we'll actually go ahead and go into that next, I suppose. So types of precipitation. So I'm going to go through on this. This is a National Weather Service website. We won't go through all the text and everything, but this is more for the graphics. So again, slightly less crude graphics. Still a little bit, but again, yeah, easy, hopefully easy to read. This is definitely easier to read than if you turn off like a SKU chart or something. So when we talk about different types of precipitation, just real fast, we have rain, obviously, and this doesn't even have rain. I think obviously the entire atmosphere, where the cloud and the rain developing is, or down is above freezing if it's raining. We have snow, we have sleet, and we have freezing rain. So we'll start out here with snow. So for it to snow, you have to have the ice nuclei, which is what snowflakes are, develop up in the cloud, and it must stay below freezing. So let's say the cloud's up here, right? So we have height. You're going up in the atmosphere here, and then this is the diagram of temperature. So this is kind of like what we call a SKU chart, I guess, in a very easy form. But when you move to the left, you have temperature getting colder. Move to the right, you have it going warmer. This black line is 32 freezing point, right? So let's say this red line here is the temperature in the atmosphere is below freezing all the way from the cloud down to the ground. Nothing is going to happen to that snow. Snow develops in the cloud, comes all the way down. It's snowing down at our house, right? So that's pretty basic. Next one, we have a little temperature inversion. Now, this is not right at the surface. This is a little ways up in the atmosphere. This is typically is occurring because of a warm front. This, I think we covered this a little bit in our fronts video. But when you have a warm front, the warm air meets the cold air and it starts to rise above it. Cold air is denser, right? It's heavier, and so that warm air wants to go above the dense cold air. And so if you look at a warm front from a vertical perspective, it is a sloping type of thing. So when you look on the weather map, you see these surface warm fronts. But in actuality, that warm front is tilted in a 3D sense, if you will. And so, wherever you see that warm front on the map, north of that warm front, somewhere up higher on the atmosphere, the warm front actually is also there. So this is where that warm air is starting to nose in. It's kind of at the leading edge of it, you'll say. So there's a thin layer of air above freezing. So we have our cloud with ice nuclei for snow. Starts out as snow. It comes through this little melting layer here. So it melts back into liquid. But then as it comes further down, you have a lot of space where it's below freezing. And there's enough space where there's time for those raindrops to refreeze. We won't get into how snow and ice nuclei form in this video, but basically, when you already have it melted in the rain, it's not going to refreeze in the snow at that point. It's going to refreeze into solid ice, and that's when you get sleet. So, basically, no warm layer above, all snow. Small warm layer above, you get sleet. I call sleet the most useless type of precipitation ever. Because nobody likes sleet. It's not good for anything. You don't make sleet balls and throw it at each other. That's stupid. Nobody does that. Sleet tends to completely ruin snowfall forecasts. This is especially here in the Ohio Valley or anywhere in the same latitude part of the country basically where we get a lot of the mixed bag precipitation winter storms. When the models are slightly off at 7,000 8,000 feet up above the ground there, and it was supposed to be 31 and instead it's 33. And so those snowflakes melt, turn into sleet, and now all of a sudden your 5 inches of snow are it's 1 inch of snow and a bunch of sleet. So I don't like that. All right, final here. You have a big warm layer of air above. So this is probably you're closer to the surface warm front, right? There's more warm air above you. Um, in this case, you have a cloud, still starts out as snow, but pretty quickly comes down, melts into rain, in the liquid rain, and then as it hits the ground, it is now in an environment where it's below freezing, but it doesn't have time to actually refreeze back in actual ice or sleet, so it falls down as rain. But because the air temperature where it's landing is below freezing, that water is going to freeze on contact with the surfaces, and so that is freezing rain. That is definitely more of a concern if you're flying than sleet or snow. I mean, snow's not good, obviously. None of these are good if you're flying.
Yeah.
But
It,
snow you can brush off. Sleet is going to accrete ice a little bit, but you think about when it sleets, they're like little ice balls, basically, kind of bounce off. Not a big deal. This is where you get that glaze of ice, and so this is bad from just a perspective of like trees and power lines coming down if you had enough of it, or even just ice on the road, or obviously ice on like the wing of your airplane or something too.
yeah, and well, sleet. I'm guessing that if sleet was heavy enough,
Yeah.
that maybe you don't have to worry about it freezing on the airplane itself to where you need de-iced or anti-iced or something like that. But where it would accumulate on the ground and kind of start to cause issues on taxi,
Yeah.
on takeoff, on landing, on those kind of things. Whereas this bottom one is kind of all encompassing. You're freezing up your airplane, you're freezing up the taxiways, you're freezing up the runways.
Yeah.
This is where stuff ends up canceling because they're like, nah, we can't clear it. We're good.
Yep. Yep. You're done. No, sleet can still be hard to. I mean, if you've ever tried to shovel when there's sleet outside,
Yeah.
wow, that is. I mean, you think you pick your heaviest cement snow, it's worse than that. I mean, it's just it's pretty bad. So that's definitely harder to clear, on when they're plowing and stuff. It smushes down, and everything. So yeah, it's definitely you're right. It's not good for like conditions on the ramp. But yeah, this is more of your everything's glazed over, and that's when we're canceling. Um, we'll do one other. Actually, here, let me get to what is so when you have freezing rain, that is kind of an occurrence of something called supercooled water. And if you're a pilot, you may have heard about supercooled water before. But supercooled water basically occurs. What it means by supercooled is you have liquid water in an area or in an environment where the air temperature is below freezing. So you would normally expect ice to exist, but the water is liquid. So this says in order for both water droplets and ice crystals to form, particles called condensation nuclei, or basically dust or salt or little particles in there, must be present. And so if they're not present, then the water can stay cooled for below 32 degrees effectively.
So
Um,
let me kind of preface this. So pilots, we hear this term called ice crystal icing.
mhm,
Um, and that's supposed to be one of the more dangerous icings that we can encounter when we're in flight. Partially because it can form on the engine nacelle, and then
yeah,
once it kind of forms on there, it can shear off and go into the engine, obviously causing other issues. And one of the things that it says to know when you're in an area that has ice crystal icing is when you start talking about being in an area where your temperature outside is below freezing, but you're flying through what appears to sound like rain, what looks and sounds
yeah,
like rain.
Yep.
And that's kind of getting into this super cooled
Yep.
water stuff.
Yep.
So
But that super cold water freezes very easily
right,
on when it makes contact with you know something anything other than air.
right,
Um, so your plane is flying at, we'll just say, minus 15 Celsius. It is the surface of the plane is probably, without any anti-ice tournament, obviously, is going to start to become the temperature that is around it, and so you have the water as it's just in the air is super cold water and is liquid, but as it hits your plane, then you're minus 15 Celsius, you're well below freezing. It's going to turn to ice.
yep,
So so one other interesting type of precipitation that I think we've joked about this because whenever we hear about it, called grapple.
yeah,
Um, they're like the little Dippin' Dots. Literally, I mean, actually, there's a picture down here. But basically, that is when you have super cold water droplets that form temperature below 32 degrees. It basically freezes onto a snow crystal. It's called rime ice. Um, and so it's like the snow crystal kind of melts a little bit on the way down, but there's also a little bit of icing developing on that snow crystal. And so it's not truly sleet per se, but it's definitely not snow crystals either. It'll go down real fast. These are types of frozen precipitation, obviously on the left front, talking about hail, but that's hail. Hail. I will say real quickly, hail is generated from an updraft in a thunderstorm. Totally different concept than what we're talking about. Um, you have grapple here, so this is kind of it's like difference between grapple and sleet. Sleet tends to be more clear. Grapple, since it's kind of that is mixing with snow, sort of, you get that more whitish look. But they're like little balls, kind of coming. So literally, I mean, it looks like Dippin' Dots.
yeah,
It does. So, and then you get sleet, and then of course snow. I mean, everyone knows what a snowflake looks like. So, that's another phenomenon that can occur. Usually, for grapple to occur, you do have some kind of sort of convective element. I mean, it's not truly the same thing as hail, but it's some people call it soft hail. Actually, it says it right here. Snow. It's often called snow pellets or soft hail. Um, and it says that they're super fragile. It's definitely like if you pick up grapple, it like disintegrates in your hand, versus like if you got true hail, it's little balls of ice.
yeah. It's basically an
Um,
ice cube.
yeah, yeah. So grapple though it is something where I can tell you whenever when I think of when grapple might occur is you have the upper level low situation where you're having little convective showers and it's like 35 degrees, something like that, and there's kind of mixture rain snow showers and you have a particularly more intense one, and that's where you're getting that you're kind of in that mixture zone, right, where your temperature of the ground is just above freezing. It's below freezing above. There's some instabilities. You have some convective type showers developing, and so that's right in the core of that shower would be the best time you get grump. So if we're going to precip types, that's that, but that's not the same as temperature inversion caused stuff like sleet and freezing
Well,
rain and whatnot.
and rime icing is something that, as again, if anybody's been flying for any amount of time, rime icing is something that you hear about all the time.
Yeah.
It's what comes up in weather reports. It's what comes up in PIREPs. It's what comes up with
Yep.
in the forecast stuff when you go to like aviationweather.gov, like
Yep.
those rime
That's your
icing is one of
classic
the,
type of icing, really,
yeah,
or most frequently you hear about.
and
Um,
it's a rough icing. So for anybody that's never seen it, when you see it on an airplane as you're flying, you'll see it looks rougher than accumulating just regular ice. When you
yeah,
accumulate regular
actually,
ice, it comes up in like a thickness kind of area, like, and it's like
this is
clear.
this is this is clear ice. Yeah, so this is
Right,
another type.
clear
Yeah,
ice. There you go.
smooth and glossy. Rime ice. There you go. So there's your kind of rough look to it. So that's from small super cool droplets. in stratiform clouds. That right there is what you were talking about, Brandon, where you're flying and it sounds like it's raining, but it's 10 below freezing outside. That's stratiform clouds or whatever. That's where you're getting that rime icing. So this actually has a kind of a funny graphic. This tells you why icing's bad. I think we probably don't need to explain why icing's bad. But decreased lift, reduced thrust, increased weight, increased drag. Lots of reasons why having ice on your plane is very, very bad. This is kind of an interesting. This is again simplified, idealized. So the world doesn't always work exactly like this, but this gives you like an idea of like icing threat for you when you're flying. Obviously, if you're above 0 Celsius, it's all liquid, good to go. The worst is actually when you're in this kind of 0 to -15 zone, and that is where you typically have super cooled liquid water, significant icing threat. As you go further up, mixed cloud phase where there's some ice crystals, there's some super cold water. And actually, when you get to -40 Celsius, all the way up here in like cirrus clouds, those clouds are true ice crystals, not super cold water. There is really almost no threat to ice developing on the plane from those clouds, at least. So,
Yeah, and Mike, I think on here there's actually a picture of frost as well.
there is that's down here.
Okay, so and I know, yeah, I'm kind of taking over a little bit from you, but and
Yeah,
I'm
go for it.
sorry, but realize that frost is a type of icing.
Yeah,
Realize that if you're going out to an airplane and you see frost on your wings, that is something you need to get rid of. And the
yep,
reason I say that is because it only takes about a quarter inch of any kind of frost or icing or anything on the wing surface itself to really disrupt that air from going over it.
yep.
Yeah, I won't get into it too much here. I'll have a different video that I'm sure I'll put a link somewhere for it. But I'll have a different video talking about airflow over a wing and how the wing actually creates lift using Bernoulli's principle and all that kind of stuff. But it doesn't take a lot to disrupt that airflow, and even just this little bit of frost here on this wing is enough to where it could mean a longer takeoff roll to be able to get those speeds you need to be able to take off.
Yeah,
It's not really something to mess with. I mean, the last thing you
no.
want to do is think, oh, it's frost, it's fine, and then the next thing you know, you're
Yeah, it's just a little tiny
in
bit
the
of ice. It's
grass.
good.
Yeah,
Yeah,
it's fine. It's just a little bit. It
yeah.
brushes off. It's fine.
Well, another dangerous thing with it is frost usually occurs on a calm, clear morning. You can kind of tell by the background of this picture. The weather typically looks beautiful.
Yeah,
I mean, it is clear. The sun might be coming up. I mean, it's gonna look like a picture perfect weather day to fly.
yeah,
You know, so frost is also that's another hard one to forecast sometimes too, because you could have situations where it gets down to freezing, but there is no frost just because there was very little moisture in the air. That's what, or maybe if there is plenty of moisture in the air, you get down to 35 degrees, but real close to the ground or near the surface of that wing, it's actually just a little bit colder, and you still get frost to form. So that's just because if you see a low of like 35, you could still have frost form when it's 35 degrees. We usually don't. We usually start if we're. I wouldn't really be worried about frost once you're above like 39 or 40. But if you have a clear night and calm winds and the air is not super dry, it gets down to 35 degrees. I'd expect some patchy frost. So,
now is that
um,
something that you could look at a temperature and 2 point spread and kind of be
yes,
able to determine how, because if your dew point's 20 but your temperature is not dropping below 35,
yep,
you're probably not going to see frost.
probably not. And as I say, probably because sometimes you get these weird, little microclimates where you're near a river or you're near whatever. There could be just a little, even a ditch or whatever, where there's some moisture collected and maybe little dew forms there and it freezes.
Sure.
But in general, yeah, that is actually one of the things that I would be looking at if I'm, you know, trying to maybe predict where we don't want to leave our airplanes out, not in the hangar at nighttime, let's just say, and we want to try to get them in the hangar. Well, if the planes are out, then it's going to be 35 in the morning, but the dew point's 15 or 20. Don't spend the money or worry about putting the plane in the hangar. It's probably going to frost because the temperatures never get to that dew point, and again, the dew point is, accurately named the point at which dew forms. So, but if you're closer, it doesn't have to be exact. I mean, 30 over a 30 degree, 35 over a 30 dew point, getting pretty close. That's going to be a pretty high relative humidity. I would expect some dew to form, and therefore it could freeze. So.
Okay.
Another type of icing. So that actually knocks out our types of icing. We went one past here on our list of things to do.
Yeah.
Um, Other thing here. So when we're talking about different types of winter precipitation, we talk. There's snow forecasting. So this kind of gets a little bit into, I guess, what we talked about on the our last video with what goes into a forecast.
Yeah.
And whatever. When you're talking about winter weather forecasting, people a lot of times want to know, like, why was the snow forecast wrong, or how do you predict how much snow there's going to be? So some major things that go into that. I guess I really should have put this middle one first. Track of the storm is definitely a big one, and not just because of like where is the precip going to go. I mean, obviously from a very basic perspective, if the precip is going to miss you to the south or to the north or whatever, it's not going to snow. But even in the even when you're, let's say you're it's gonna precipitate, you're gonna get some rain or snow or whatever. Where that area of low pressure goes that's causing that precipitation is going to impact the temperature profile of the atmosphere. So we'll go back to these charts here. If the low moves 50 miles from where it should have been, you could go from having this picture here to this picture down here. You know, because if you think about with the low and the wind going around it and all of it's moving different air masses and different temperatures and whatnot. There's a lot going on around that area with low pressure, and so where you are in relation to that low is going to vastly change what the temperature profile of the atmosphere is, and therefore what kind of precipitation you're getting. Go back here to this thing here. So track of the storm matters quite a bit. And then there's snow to liquid ratio. So I think most people know when water freezes, it expands. So when you're talking about how much snow is going to fall, we typically boil it down to the liquid equivalent. So when we look at like a computer model, we talked about this, in the other video. We look at precipitation here. Actually, we'll do total precipitation. So here's a total liquid, we'll call it liquid equivalent precipitation. Now, in this case, all this is falling as rain, but let's say we're looking at this map here. It says over Ohio, it says 0.72 inches of liquid is going to fall, but maybe that's all going to fall as snow. On average, snow is it's a 10-to-1 ratio when you're talking liquid falling as snow versus, or precipitation falling as snow versus liquid rain. So that 0.72 inches of rain would in that case be 7.2 inches of snow. And because of this, small variations in the total amount of precipitation can have a much more magnified impact on how much snow you have. So you have 0.47 inches of precipitation down here, 0.78 up here. Nobody really cares, right? Nobody cares if you got 7,807 inch versus 4,707 inch, right? But you probably do care if you got 4.5 inches of snow versus almost 8 inches of snow.
Yeah,
it makes a big difference. So that is a key driver behind the accuracy of that snowfall forecast, and even just how much snow you end up getting. Another thing we call banding, where you get these little bands of heavier precipitation that can I'm going to say randomly set up inside of the broader area of precipitation occurring, and that's where you get those little zones where it's like, this neighborhood got 8 inches of snow versus everyone else got like 6 inches of snow, and that happens with rain too. But again, it doesn't really matter, right? Like, nobody really cares that they got an extra quarter inch of rain. but they do care they got an extra 2 to 3 inches of snow. Now, the colder it gets, the higher that ratio is. I've actually seen, I mean, if you get like Arctic cold air, you get that real dry kind of pixie dust type of snow. That is like 25 or 30 to 1 ratio of snow. And that's where in like the atmosphere can, you can have this really teeny little disturbance come through in the winter or in a super crazy Arctic air mass, and it'll actually squeeze out like an inch of snow from like almost nothing. Yeah, I mean, there's very little actual moisture and liquid equivalent precipitation falling, but you get that inch of snow that ruins the morning rush hour. Um, so the snow to liquid ratio is, I guess, as probably it kind of makes sense. At least in my head, it makes sense. The lower that ratio is, the more liquid there is in that snow, and so that's also when we talk about there being a dry snow versus a wet snow, right? Is it easy to shovel or is it hard to shovel? Is it good to make a snowman or is it not? High ratio snow is the dry powder that all the skiers like, but everyone else hates for like playing in. And that low ratio, like 10 or even sometimes 7 to 1, is that like kind of like cement type of snow that falls that you break your back on trying to, or clogs your snowblower if you are shoveling.
Yeah.
But 10 to 1 is kind of the average, particularly for the middle part of the country. I mean, if you live up in, if you're watching this video from International Falls, Minnesota, you probably get 20 or 30 to 1 snow pretty frequently in the summer, or sorry, in the wintertime. Versus someone who lives in Atlanta, lucky to get a 10 to 1 snow event. So, but because of that, again, any kind of change in the track of the system where you're getting just a little bit more precipitation, or the model was just off by a little bit, that the error in the model is magnified because it's now 10 or 15 to 1. It's 10 times more of an impact, if you will, kind of. We're talking, instead of a tenth of an inch of instead of being off by a tenth of an inch, it's off by a whole inch of snow. Or if it's off by a third of an inch, it's off by 3 inches of snow. That's one of the reasons why you always see a snow forecast with a range, like 2 to 4, 1 to 3. Now, Brandon, you can't tell me when I say 2 to 4, you only hear 4. I know it.
Yeah.
Sometimes I'm like, maybe we should just do it 4 to 2. Like, do you hear the last number? Like she's at, we're gonna expect 5 to 3 inches of snow tonight. Yeah.
No, I think it's definitely the biggest number is usually what
It's the
gets
biggest
stuck.
for sure.
Yeah.
Yep.
Yep. 5 inches. Oh, that's it.
Yep.
He said 5 inches. Well, it's,
Yep.
it's 2 to 5. No. 5 inches.
Yep. And the thing is, in most cases, if that forecast really does pan out, the 3 to 5 or whatever, if it really falls in that range, the range was the correct forecast to give, because again, there is never a uniform perfect distribution of precipitation over an area. There are little variations, just random pockets of heavier precipitation, or a little hole developed here. There's no way to predict where that's going to occur. So, a spot on forecast would be, this side of town, there's some reports at 3.5 inches. This side of town, there's some reports closer to 5. That's why there's a range. It's not just because of uncertainty. It's because there truly is going to be a range between 3 and 5 inches of snow that falls across the city when you get this forecast like that. So it's not all just uncertainty. I mean, it's a little bit, right? I mean, there's a little bit of that uncertainty, but it's also there really is going to be a range. There's variation, if that makes sense.
Yeah.
So, and so that is one area where small amount of air can cause a big change to the forecast. The other thing, which I kind of already touched on, small amount of air on any normal day, if the models are within 2 degrees or whatever of being correct, the model says it's going to be 65 tomorrow and the high is 63, I'm pretty sure Brandon's not going to call me complaining. It was basically as warm as he thought it was going to be, right?
Yep.
But at this random point in the atmosphere, we'll just say 5,000 feet up. If the model thinks it's going to be 31 and it ends up being 33, now instead of snowing is sleeting, and that is a common occurrence. That'll on any given day, the models could be off by a degree or two, 5,000 feet up in the atmosphere, and it really doesn't matter. But when you're getting into a winter storm, it really does matter. And so that's when you can that's a tiny error, high impact to the
Yeah.
actual outcome of the weather. I mean, I can think of one here in Ohio. I don't know if are you were here, Brandon? Or if I knew you, might have been the year before. But I mean, it was one of those where models are showing huge, like 12 inches of snow, which is exceedingly rare for us. I always downplay that until the couple days before, because honestly, like, I mean, you can just play the odds. You're probably going to be wrong if you call for a foot of snow here in Ohio.
Yeah.
Um, but it has happened, it can, and there was a case where it really was starting to come down to the wire, and it was like, wow, I think we really could get like 10 or 12 inches of snow. And then when it finally the snow gets here, it starts to snow. We get like an inch or so on the ground, and what do you hear in the window? Pitter pat, pitter pat, pitter pat, and you're like, that's not snow falling. And you go outside and you're like, well, crap, it's sleeting. And there was just a little warm layer in the atmosphere that the models missed. And we ended up with a 12-inch snowfall forecast. I think we got maybe an inch or two of snow. We got a solid like half inch of sleet. I mean, like it was a lot of sleet. I mean, it was just full on sleet storm. But that was a case where just a tiny little error. The precipitation totals were all correct. The track of the low was very close to being correct, but there was just a little tiny bit more warm air in the atmosphere than what was shown, and it blew the whole forecast.
Well, that's probably one of those things too, where if you can take the amount of sleet and be like, okay, if this would have fallen as snow,
Yep.
it would have been 12 inches.
Right.
So
That's why it's easier to boil it all down to a liquid equivalent, more of a commonality. I
yeah,
want to say sleet is like it's something like 3 to 1, maybe. It's not nearly as high a ratio as snow. So half inch of sleet would be quite a bit of snow. So yeah, I mean, if you boil it, and usually any major airport with an ASOS, it's going to report liquid. It melts it all down. It reports what the actual liquid amount is. That's how you get your annual precipitation amount for the year at any given location. It melts everything down in the wintertime. And so yeah, at the end of that event, I think we were somewhere around an inch or 1.2 inches of liquid equivalent. And if that had all fallen to snow, multiply it by 10, that was a foot of snow.
yeah, yeah.
So,
No, I wasn't there for that one. There was one, I think it was last year, maybe this past winter. It was supposed to be 4 to 6 inches. And we like shut down the department, like everybody just stayed at home, like we
right.
just worked from home. But yeah, that's not at all what we got. We got like 2 inches on the ground or an inch and a half on the ground, whatever it was.
Well, and sometimes you get when you're right on that line, and this is where we talk about the track of the low, right? In the last 6 hours or 12 hours, the model will start to realize, oops, the low is actually going like 30 miles north of where we thought it was going to go. So now everything associated with that storm, where the freezing point is, where the mix line between sleet, freezing rain, snow, whatever is all shifting with that track of the low. I mean, you can go from there can be a very sharp cutoff, and so when you move it just a little bit, all of a sudden instead of getting 5 inches of snow, you're just raining,
Yeah.
or maybe you get that 1 inch of snow and then it changes over to rain, and so and I will say I think in general the news media and especially the weather service can sometimes be a little slow to adapt to that last minute crazy shift just because their messaging has been what their messaging is. They don't want to look like flip flops, right? And just be like, oh, just kidding, it's not going to snow. But what you'll see, like what I tend to tell people, I mean, if I'm getting in that, it's 12 hours out or whatever, and it's starting to very clearly shift. Sometimes you just got to pull the plug on the forecast. Be like, I know I said it was going to be 4 or 5. It's going to be 1. And I would rather do that than just continue to blindly say, oh, no, it's going to be 4. It's going to be 4. And then be completely wrong. So
Yeah.
yeah, my forecast was wrong from a day ago, but at least I gave you a heads up that the situation has changed, and now it looks like it's going to be just an inch. So,
Yeah.
well, that was at the time when I basically told you like you're going to get almost nothing, and you were like, "But the Weather Channel on TV station says I'm
Yep.
going to get 4." I was like, "You're not going to get any snow, Brandon.
Yep. That's
I'm sorry,
exactly
it's
what it
just not.
was.
It's not going to snow at your house." And then,
And
sure enough, you were like, "Son of a gun, Mike! It didn't snow."
yeah, I got just enough to
Yeah,
cover the road, and I was just like,
yeah,
nah, I'm not going to work. I'll just work from home. And then lo and behold, that was all we got.
yep,
And it was just like, well, crap.
yep. So, winter weather is it's very it's can be very challenging and therefore sometimes very frustrating to forecast, but it's also there's a lot that goes into the prediction of everything. So I find it very fascinating, but I mean I'm almost just a weather nerd, so I find those kinds of weather fascinating, obviously.
Yeah.
Um, but yeah, so that's kind of the gist of it. Snow and ice forecasting and temperature inversions and all the impacts and whatnot on flying. So, did you think of any questions, Brandon?
No, I mean, it was good. I like, I like going into that kind of stuff because, depending on where you learn to fly, that has a huge impact on the type of weather you fly in. I know a lot of people told me in the beginning they were like, you need to go out to Phoenix or you need to go to Miami or you need to go to, X warm weather place. And they said, "Oh, you'll never cancel. You'll always your weather's always gorgeous out there and you can always fly in
Right.
good weather." And that's great because it gets you through your training. But there's something to be said about guys that train in basically bad weather areas, um places that deal with a lot of rain, places that deal with a lot of snow or ice, or the combination, kind of like where we were in Ohio, where that band is always kind of just a subtle adjustment up or down means that you're either in ice or snow or you're in rain.
Right.
So like one day I may go out and I'm in rain or I'm in a clear weather. The next day I go out and I'm in snow. And to me, that just makes you a better pilot.
Yeah.
It makes you pay attention to things a little bit more. Now, granted, that's just from the little bit of stuff that I have. Like I said, I've got about 45 hours in a Cessna, so it's don't don't come
Yeah.
after me in the comment section saying how wrong I am. Um, but at the same time, the argument stands for a lot of things. It's fair weather doesn't, or was it calm seas doesn't make a good sailor. Fair
Yep.
weather doesn't make a good pilot.
Yeah.
So if you fly your entire career in Arizona, and then all of a sudden they're like, "Hey, you are fired. You need to find another job," and you find something in Alaska, your way of flying is completely different. And
Or
especially
even really, I mean, it's all well and great that to live down in Phoenix or Miami, but let's be honest, the reality is people move. The reason you fly is, especially if you're flying passengers, is to go to other places,
right.
and those other places could very much not be Miami or Phoenix or
Exactly.
Houston. It's like, um, and when we get into the winter months, really the vast majority of the United States is going to experience some kind of not very pleasant weather. I mean, okay, Miami maybe not too much, but I mean, you're in January, you got low clouds and rain, low IFR in Atlanta frequently,
Yeah.
and that's pretty far south. I mean, you definitely gonna have snow and ice in Kentucky. Obviously here in Ohio, we get everything. We call it the kitchen sink. Um,
Right.
there's plenty of major destinations that are further north that get just winter weather all the time, all winter long. So,
Yep.
the odds of you flying from Phoenix to Miami all the time pretty low.
Right.
So,
Well, and so the company I currently work for, or contract with, they they fly a lot in the Caribbean. They fly a lot in South America. And most of the places they go in South America are somewhere around the equator. So they're
yeah,
they're leaving Miami and they're going to warmer weather areas. However, they have bases that are in cold weather areas too. And
Yeah,
it's one of those things where, you get used to one thing and all of a sudden you're in a completely different environment.
that's
All
true.
I would say is that if you're just starting out, if you haven't had the experience of big airplanes where you can fly long legs and go from a warm weather to a cold weather environment,
Yeah,
just realize that when you do, ice and snow and sleet are not things to really mess with. These are things you really need to pay attention to in your weather forecast. You really need to pay attention to what either ASOS or ATIS or whatever weather you have um, at
yeah,
that station. You really got to pay attention to that stuff because this is the kind of stuff that really accidents happen in this kind of weather.
yeah.
Um,
Th
you know,
This is the stuff like we were joking, but also serious. Like this is what cancels your flight. I
yeah,
mean, because it's
it's
just simply not safe to fly.
it's what
I think
cancels it's what
for where
cancels
I
your flight
work,
or kills you for that matter.
right, yeah,
I mean,
where I work and where we both used to work, I think this is similar for quite a few operators out there. The cutoff is if it's moderate level, any ice type precipitation, not snow. Snow's a little different. That's more visibility driven. But if it's moderate sleet, moderate freezing rain, done. I mean, if the ASOS is reporting, moderate sleet or moderate freezing rain, I don't even care. We don't care what the actual conditions are on the ramp or whatever. There is simply too much ice falling from the sky
right,
and therefore beginning to accumulate. That is just this is just deemed not safe. Basically, the odds of your de-ice failing are greatly increased because there's just too much ice being you're being hit with too much surface icing. When I say surface, I mean like at the ground.
right.
When they see you're rolling out for takeoff or whatever, if there's moderate freezing rain, I don't care how much awesome de-ice they put on your plane's being hit with active icing
Right.
pretty heavily at that point.
Yep.
So it's just no longer safe to go.
And
So you have to
again,
wait.
there are things out there that are for reference for pilots too, where there's icing charts and what's the word? The type of fluid you use, whether you use type 1, whether you use type 4, whether you
Sure.
use, whatever. There's holdover
Yep.
charts. There's
Yep.
all these things that go into winter weather operations. And I know, we talk and we jest and we laugh about how, off of forecast can be and things like that. But you got to understand, like, these things, they're forecasted by people, and people can make mistakes.
Yep.
Computer models, if you watch our last video, we talk about computer modeling and how, for like, all the stuff that goes into forecasting, how they can sometimes be wrong.
Well, as the computer models, while that what it, I maybe that is a computer technically making the forecast, but a human created all of the assumptions and all the formulas that go into that model, and so therefore there is inherently human error in that as well.
and right,
Um,
exactly.
and observation. I mean, it's like we said in the last video, garbage in, garbage out. If there's bad observation data, really, as good as the computers are ever going to get, and as much as we know about the atmosphere, you're probably never going to have perfect forecasts unless we somehow manage to make a super tight grid. If there could be like an ASOS every couple miles
Yeah,
across the entire
right.
globe, that would be perfect because the problem is we only have so many observations. We talked about, I think this is the last video with the weather balloons.
Yeah,
There aren't that. There's like what, maybe 30 locations in the US where weather balloons go up. What the atmosphere is doing in between those is effectively in what's called interpolated, or if it's minus 10 here, it's plus 10 here. We're going to assume it's zero right here. You know what I
zero in
mean?
between. Yeah,
You have to interpolate the data in between. Now, there's a little bit of extra input from like satellite and aircraft data that can kind of help smooth that out a little bit, but um, that's where you get that little warm layer that we didn't know about from the sleet. Is just there wasn't an observation, of that warm layer to that level of precision. You know what I mean? Like we had the weather balloon down here, we had the balloon up here. We think the warm layer is right about here, but I don't have something to actively measure exactly where that is, and so the model is taking that assumed condition as its initial starting point. If the assumed condition is not totally correct, that's it's all downhill from there.
Yeah, yeah,
So
and this doesn't affect. Well, I shouldn't say that. It has the potential of affecting smaller airplanes more than it does larger airplanes, and the reason being is larger airplanes generally have some sort of anti-ice de-ice system on them.
yeah,
Whether it's the engines, whether it's the wing, whether it's the rudder, whether it's all the above, there's something that de-ices the airplane. Whereas like smaller airplanes, they're relying strictly on the forecast. So if they take off and the forecast says there's no icing up to this altitude, and then all of a sudden they get into icing,
yeah,
the results of that can be catastrophic. And I'm not trying to make it dark or anything like that, but I mean that is something that could potentially kill you um
yeah,
in this industry. We always preach safety's first, safety first, safety first. But let's be honest, if safety was first, we would never fly. Like, I mean, let's just be honest.
yeah.
You can't take hundreds of pounds of machinery or thousands of pounds or hundreds of thousands of pounds of metal, put it in flight, and be like, yeah, this is 100% safe. Like, that's just not going to
Totally
happen.
fine. Yeah,
So it's all about mitigating risk, and if you can mitigate that risk by paying attention to forecasts and paying attention to charts and that kind of stuff, then you'll be better off for it, I think. But again, there we could probably talk on this for another couple hours for that matter, but we're not going to bore you with all that. We're going to go ahead and we're going to cut it off here.
I guess we could have gone into like thunder, snow, like and the video
Oh,
of Jim Cantori freaking out.
thunder snow, that is so great. um I
It's a
think
real thing, and I have actually seen METARs because it thunder snow is more common than other types of freeze precipitation. But I have seen TSIP or TSFRZA. So thunderstorm with
thunderstorm,
sleet
freezing rain.
or thunderstorm freezing rain. Usually it's out in the plains because they get all the really cool, crazy weather out
Yeah,
there.
right.
But totally, I mean, the forces that cause thunder and lightning can still occur when it's below freezing. And um, we'll put it this way: I would definitely not take off if there's thunder, sleet,
Hell
or thunder,
no.
freezing rain.
No, not at
So
all.
definitely, or even thunder, snow. To be honest, thunder, snow typically is you're gonna have some pretty heavy snow. So
Man. Well, again, this is all something where if you want to hear more about this, or if you want to have us tackle a different aspect of this, like, subscribe, put a comment down below, let
yeah,
us know what you want to see, what you want to hear. If you think we're completely off base, let us know that too. I've got, for those that this is your first video watching, I've got like almost 20 years in aviation. I've got 10 years of being on an airplane, flying around, not actually being the pilot, but flying around on big airplanes and then teaching big airplanes. So, I mean, if you think I'm wrong, please let me know in some way,
yeah,
shape, or form, and we can always discuss it. Um, but just keep an eye out for stuff. Obviously we're going to try and put out as much content as we can, and then even when Mike's not available, I'm still going to try and put out stuff that will hopefully be informative and will help I don't know, make better decisions in an airplane.
I mean, I'm not
However
gonna
you want
lie,
to look at it.
we're gonna start to run out of predetermined things to talk about. But if you got something if you're like, I want to know more about thunder snow, or I want to
Yeah.
know more about like why did Mike say this occurs? Sure, give us something to talk about. Well, I'm sure we can talk about it.
Oh yeah. Yeah, we can
So
get into some of the nitnoidy stuff and really dig in a little bit more into certain things if that's what you want to
yeah,
hear. Other than that, once we get through a lot of these major subjects and we get through that, my idea is basically if there's a weather event that we need to talk about or that we can talk about, then that's something that we'll make a video out of.
yeah,
This wasn't really meant to be a series that was going to be perpetually going. But hell, if you want to talk about stuff, we can talk about stuff. We
totally.
can always figure it out.
Yep.
But on that note, let's go ahead and cut it off here. And again, it's Weather Wednesday. It's episode 6. If you haven't seen the other 5, I'll put a link. I think this is the correct side that it's going to be on. I'm going to put it right here in a little card that'll take you to the playlist. We've got 5 other videos. We talk about METARs, talk about pressure systems. We talk about, oh God, ice. We talk about all kinds of different things. And you can check those out. If not, just go onto the channel and you can find all the videos there as well. As some other
No,
videos.
you're not losing your marbles. Brandon is ice was this video. I'll let
That's
that one
true.
slide. It's okay.
Sorry. Yeah, ice was this video. It will be in this playlist that
Yes.
shows up. But it's I don't know. We'll see how it goes. We'll talk about whatever you want to talk about. But
Yep.
outside of that, man, Mike, I appreciate it again. I really enjoy
Sure.
having the conversations with you and talking about this stuff. And I always feel like I learned something, and that's always a good thing. So hopefully everybody else does
There we
too.
go.
And yeah, we'll see you next time, guys.
See ya.